Hi folks, and welcome back to Math with Captain Rod. Making this video here to provide another example of sketching polynomial functions. So what we're going to do is we're going to take a look at this function here, m of x equals minus 2x times the quantity x minus 1 times x plus 3. Now, what you call this on the left doesn't matter. M of x, h of x, g of x, these are just other names for y on this graph here. And before we talk about details, let's talk about the LTB here, the long-term behavior of this function. So by the time we multiply all this out, when we multiply this out, the lead term is going to be an x squared, and there's another one that's going to be an x cubed with a minus sign in front of it. So this function looks like minus 2x to the third plus a bunch of stuff, where this bunch of stuff will be squared and linear and constant terms. That's the important thing, right? This is an odd function. X to the third has this type of behavior. Minus 2x to the third will therefore look like this, because remember the minus sign is a reflection about the x-axis. So the long-term behavior of this function, we know it's got to go basically this way, quadrant 4, this way into quadrant 2. Then there'll be some detail here in the middle. Now we'll kind of start working on the details. Intercepts. So the y-intercepts here, the x-intercepts. Remember that anywhere on this axis y is equal to 0. So if you I'll just do this. Imagine putting a 0 here and solving the resulting equation. One solution is x equals 0. I'm going to put that on the graph. And it's multiplicity 1, meaning that this thing does change sign here at this. It either does something like this or this. And we'll get the details in a minute. X equals 1 is another intercept. Again, multiplicity 1, and x equals minus 3. So there's the intercepts. Now, so that's probably pretty much enough to kind of sketch it here. It'd be nice to know, between these we have turning points. So 1, 2, 3, we might put like 1 minus 1.5 into this function, or minus 3 halves, and see what we get out of that, just to see how far down we are over here. So m of minus 3 halves is going to be minus 2 times minus 3 halves times minus 3 halves minus 1 times minus 3 halves plus 3. And again, what we're doing is kind of inspecting where the function is halfway between these 2 points here. Oh my goodness. Let's simplify this guy right there. Common denominator would be a 2, so that's negative 3 halves minus 2 halves. That's minus 5 halves. Talk about that one. Common denominator, again, a 2. So that's minus 3 halves plus 6 halves. That's 3 halves, which is 3. And it's positive. All right, now let's talk plus and minus signs. Plus, minus, minus, minus. So the ultimately this product is negative. And let's see what we get about this. Now the numerical values. Let's see, these will cancel. So we get 3 times this is 15 halves times this is 45 fourths. Hopefully I did that right. And I'm just going to grab myself a decimal number here for the graphing. Looks like minus 11.25 out of that. Hopefully that's correct. All right, so we know that minus 3 halves and minus 11.25 I think is just off my scale here, maybe something like this. Minus 0.5 would be another good one to run through this function, because we want to know what it's doing right kind of halfway between these. So let's see, m of minus 1/2 or minus 0.5. Good grief, huh? All right, so we're going to have, I'm just going to do this. Minus and a minus is plus, and then 2 over 1. That's going to give us plus 1 right here when we put a minus 1/2 in. Let's see, if we put minus 1/2 here, that's going to give us minus 3 halves. And if we put a minus 1/2 here, let's see, that's 2.5 or 5 halves. So it looks like we're going to get minus 15 fourths. And that is, what is that? Right, so that's minus 3.75. So that's going to put us 1, 2, 3, about here. Not what I was expecting here, because this was an odd multiplicity here. Let me check my plus and minuses again. So putting minus 1/2 in, we're going to get plus, minus, plus. I'm sorry, that comes out positive. Plus, minus, plus. Yeah, that comes out to positive 3.75. So 1, 2, 3.75, about right there. There we go. All right. Get rid of this little dot there. I think we got enough to kind of sketch it. Remember our long-term behavior. This thing's got to basically come from this direction, and it's got to end up going in this direction. So our sketch is probably going to look something like maybe this. Goes through the 0. Goes to this point, through the 0. Down this way, this way. I could grab some more function values to the right or left to get a little more detail here and here, but I'm not going to. I'm just going to call it good. Again, this video is really about just how to sketch a graph. I had really intended to not even maybe use a coordinate axis on it. So I think that's good enough. I'll leave it as an exercise to the person watching this to run this through a graphing utility and just make sure you got something reasonably close to this. Again, it was not meant to be perfect, just meant to be a rough sketch. Should have the zeros in the correct locations, these points in the correct locations, down and right, up and left, and then I would consider it pretty well good. So hope this video helps demonstrate how to sketch these graphs. Have a great day.